Okay.
All right.
Okay.
So welcome to the Software Speakers Show. This is a show designed to help engineers become better communicators. And today I have the honor of presenting to you a gentleman who is a master in what I would call the black arts of analog design. But this gentleman holds both a bachelor's and a master's in electrical engineering. He's written 3 textbooks on engineering. He's also been a product marketer.
A marketer.
Is that correct? And
yes.
So with that, ladies and gentlemen, Mr. Bill Schweber.
Thank you very much. Pleased to
Thank you.
see you all. I've always wanted to be an engineer, either electrical, mechanical, and as a teenager, I did a lot of messing around with stuff. Back in those days, kids were allowed to do a lot more dangerous stuff than they were now. My father had a factory with machines in Midtown Manhattan. I'd go down and visit and help him out, get a lot of tools. And nearby was a chemical supply shop. And you'd go there as a teenager and say, I'd like a gallon of copper sulfate, and he'd give it to you for electroplating. And
Wow.
he'd say, no, be careful on the subway with it. Now he'd probably get arrested. But I think, the parameters of what you could and couldn't do were a lot wider back then. Also, when I was 12 or 13, I had a Dremel moto tool similar to this one. The original one is long gone, of course. And using that, I was able to grind away rivets and take things apart. And it was a lot of fun. And now, if you gave a 12-year-old a Dremel moto tool, you'd be arrested as a parent, probably. But in my one thing I found in my many years of engineering, the biggest problem is, in terms of communicating, a project that an engineer works for a year or two is like their baby, and they want to show you all the baby pictures, and they want to tell you all about their vacation and stuff like that. And frankly, the audience is either not interested or overwhelmed by too much information. The biggest challenge when you're communicating to the audience is not only the obvious, find out what they're looking for, what their expectations are, but also to find that sweet spot between having very in-depth discussion of a given topic, which will appeal to 6 people, versus having a very broad discussion, which is only an inch deep, which will cover a lot of territory, but then the audience, or whether it's one person or a lot of people, will say, I heard a lot of stuff, but I learned very little. So finding the sweet spot between breadth and depth is always the challenge when you're communicating, whether it's verbally, via PowerPoint, or via a written article. It's especially difficult when you're using something that's posted on the web in writing, because you don't have audience feedback. Whereas when you're presenting at a conference, you get some feedback by how many eyes glaze over at a given time. When I was in corporate marketing, as an engineer, first of all, it made it a lot easier, because this was a very high-tech company. And if you didn't have an engineering degree and experience, they wouldn't talk to you as a marketer. But I found the biggest challenge was that the product engineers were so wrapped up in their product, they couldn't help talking about it. They loved talking about it, but they would go into too much detail, and they'd throw model numbers around and things like that. And the audience didn't know what they were talking about. Not that the audience was not smart, they were smart, but you'd say, I worked on the model XYZ, and the ABC has this parameter and this. They say, is this ABC an A to D converter? Is it an op amp? So you've got to be clear at each point what you're talking about and provide context to the audience. And that's the most important thing I learned in marketing. And I've used that skill when I became a technical editor to understand who is the audience, what are their expectations, what is that sweet spot of giving them enough information. They say, I found that useful, but not so niche-y that I can't do anything with it. And finding that sweet spot is often the biggest challenge when I write for clients. I often do an outline for some, and I spend a lot of time on the outline, not because I needed to write, but I needed to get them to understand what is it you're trying to convey to the audience. How much background do they need? Is the audience technically knowledgeable and doesn't need a lot of background? Or are they not so knowledgeable and need a lot of background? So you have to understand your audience's knowledge level and expectations, then match what you're providing them to those things. Now that seems very obvious, but actually it's not. I've heard many presentations which were either way too deep, way too niche, or way too broad and thin, or the audience says, I'm a smart guy, but I have no idea what this guy's talking about, because I don't know anything about that level of device physics, for example. So that's where I come when I communicate. So I keep going?
That's cool. Yeah, well, I want to ask you specifically, so how did you go from just being an engineer to being an engineer who writes and all this?
I've always done a lot of reading about engineering achievements. History of science and engineering is one of my personal interests. So that gave me a lot of insight. And I would do, as I did the reading, I would read stuff that was coherent and legible, and stuff that was not so coherent and legible. And that gave me insight, number one. And number, how did I transition, or why did I transition? Basically, many years ago, I was hunched over a circuit board with tiny components that you could barely see, and you couldn't probe it, and there was no fun in that, frankly. I like probing around. Analog guys like to probe.
Yeah.
And when you can't put a probe on a part because the probe itself will completely distort the part's performance, and the fun is out of it, frankly. Or you and I like to tack a resistor here or there, and I tack solder it. I was very good at soldering. And when that ability was taken away by the availability of tiny surface mount components, I said, I don't think I'm going to be doing this anymore. Plus, frankly, there was too much software involved, and I liked all analog circuits, and software is encroaching and taking over a lot of the analog roles. So I said, I don't think so. So I merged the fact that I wanted to move away from hardcore hands-on engineering, the fact that I liked talking about engineering and engineering accomplishments, and that was my path to getting away from hands-on engineering to engineering editorial and writing. And I wrote a few articles for one of the trade publications as an outsider and submitted, and they ran it. I said, I can do this. You know, for example, I'll give you an example of bad writing. There's a book by Davis Sobel, this woman, about the clock, the highly precise clock that John Harrison developed in the 1700s to win an award to figure out longitude. The book is called Longitude, incidentally. And in true New Yorker writing style, she takes 3 to 4 pages to lovingly describe every gear of this clock, when one picture would have been better. And I said, this is bad. Only a reader of tremendous patience and attention could follow this. Whereas one diagram with a few parts would have been good. So that to me is an example of a bad discussion. On the other hand, the late unfortunate Jim Williams, the legendary designer, was a fabulous writer. I'd read his stuff all the time. And he talked about, here's what I did, here's why I did it, and here were the trade-offs. The other thing I find in a good engineering story, not so much you're talking about a product per se, but you're talking about an engineering design, is the audience engineers like to hear about the trade-offs, because engineering is about trade-offs. There is no, this is the only answer. Every answer is about trade-offs. And I think one of the most difficult engineering skills to develop as a new engineer out of school is understanding trade-offs, because that's not really taught. And there's no single trade-off. It's a trade-off between power, cost, real estate, many other factors. And balancing those trade-offs and how much you're willing to give up in one to achieve something in another is truly the engineering challenge. And when you can describe that to the audience, they love it. So for example, if you read about a space mission, they talk about cost, but in reality, it's all about performance and power and reliability and confidence. They don't really care about cost. You know, that thing's going out for a 20-year ride. There's no repair. It's got to work fine, like Voyager 1 and 2, 40 years out, still sailing along and sending back signals. On the other hand, there are cases where, you know, size is very important, or real estate, or weight. So understanding the trade-offs and how you weigh the trade-offs is the true engineering skill. And when you can describe that in a story, the audience loves to hear that, because that's what they face every day. I think the other thing that's good to describe when you talk to engineers is understanding when the project is done. You know, there's no finish line marked till you're done. Every project has a different finish line depending on the time constraints, the criticality of the project, you know, where it's being used. Obviously, a consumer product has different criticality than a medical product, for example. And when you can talk to engineers about how you decided the project was done enough, that's always very good. There's a book I read many years ago called The Soul of a New Machine by Tracy Kidder. It talks about mini computer design at Data General, long gone, versus digital equipment. And the protagonist in the book, whose name I forget, his big job with his engineering team at Data General was to help them face up to, when is the design good enough and qualified enough that we can release it? Given that it's hard to update hardware, we can update the software. Where is that sweet spot of, yes, let's release it to market now? And understanding that, we can describe that to the audience, they love it, because that's what they face every day. You know, some people say you can't release it till it's perfect. Well, no product's ever perfect. So the question is, what degree of perfection in what area are you trying to achieve? So you could say it's done at the design review. And that's what I try to convey in a good story.
That's really good. You mentioned these 2 books. You enjoy reading a lot about engineering.
Right.
And you say that reading these has helped you in your own writing.
Yes.
Are there any, besides these 2, are there any other books that you would recommend to other engineers to help them in their communication?
Actually, believe it or not, the best book or essay I would recommend is not about engineering. It's an essay by the detective story writer Raymond Chandler. written about 1935, 1940. It's called The Simple Art of Murder. And in this essay, which is about 20 pages, he very clearly defines the point he's trying to make, pulls in evidence to substantiate it, refutes other evidence that he feels is meaningless or contradictory, and makes an extraordinarily coherent case for what he calls the modern detective story. And he basically, shoots down the old lady solving murder mystery as being laughably idiotic. He says, this woman would be laughed out of any police station. She has no access to evidence, to warrants, to whatever, and yet it was very popular. And he talks about what makes a good detective story. And in fact, a good detective story, he says, is one where you'd read it even if the last chapter was not available, because it creates an atmosphere, creates a sense of reality. It makes the case. But the point is, his essay, The Simple Art of Murder, is wonderfully written. It's clear, it's sharp. It doesn't engage in trite cliches. It raises the issues, establishes the points he wants to make, and substantiates the points he wants to make. So that essay, even though it has nothing to do with engineering, taught me a lot about good writing. The other non-engineering thing that taught me a lot about good writing was an essay by the legendary author George Orwell, and it's called Politics in the English Language. And he talks about good writing versus bad writing and how easy it is to fall into cliches, and how cliches are a form of lazy writing, and in the end, cliches are a form of misleading writing in many ways. And even though that essay is dated, it's also from the mid-30s or thereabouts, Orwell makes a very strong case for what constitutes good writing. And those non-technical essays really taught me a lot about good writing for your audience. Now, there are writers who write for themselves, and that's fine. It's called a diary, and that's great. But when you're doing what I do, you're writing for an audience, usually on behalf of some third party. So you're trying to convey the third party's message, and that's important. There's nothing wrong with tried and true stories. Among the most popular stories I've ever written, according to the person I wrote it for, was a basic tutorial on how do you size a current sense resistor. What are the issues with current sense resistors, which is a standard technique for measuring current through a motor or whatever, or load. And it turns out there are trade-offs involved in terms of power dissipation, self-heating, IR drop, etc. And talking about those trade-offs and how you saw and what are the issues, it makes for a good 1,500-word story, which is about 4 pages. And engineers say that's important information. I didn't understand the angles involved and why you end up generally with a certain size resistor, but it depends. And there are conflicts involved and some issues to resolve. So that's a kind of clear-cut thing. Sense resistors, choosing and using them is a great story. The other thing I found in writing is, it also sounds trivial, is that the headline is very important. Now, that sounds trivial. What's the headline? In fact, the headline's important. I tell every client I work for, because it sets the tone for the story. Not only does it tell the audience what you're going to tell them, talk about, but it sets in your own sense that's what you're going to talk about. And you'll know if you're going to talk in the headline details about designing XYZ, well, that's one thing. If you talk about issues involved when choosing XYZ, that's another thing. So the headline is an important part of the story. Back in the day, among my corporate marketing things, I wrote press releases, and I read thousands of them, and I wrote hundreds. And there were times when I would work on a headline for hours, because you've got about 20 words to capture what the product is, what it does, and why it's significant, and to whom it's significant. Those are 4 things you're trying to capture in give or take 20 words. And let me tell you, that's very hard. And part of it's keyword search, but part of it's the audience. They see a headline, they go, yeah, I want to read that. That's important. Sometimes a headline is catchy, but you have to be careful, particularly in the days of SEO. Headlines which are clever wording, which make use of puns, which involve twists on English, don't work. They don't work for SEO. They don't work for the non-English standard speaking audience. So you have to have a headline which is clear English without puns. I love doing puns. You can't do puns in headlines. It don't work. They mess up SEO. The audience doesn't get it. No inside jokes. Journalists and reporters, and I don't have a high opinion of journalists, frankly, they love to have clever headlines that show how clever they are. Unfortunately, they're only showing themselves and their coworkers how clever they are. The audience doesn't get it in many cases. I did a blog a couple of years ago about a dishwasher installation that a dishwasher company did, not me. And the headline was 4 words, 3 wires, 5 mistakes. And that got tremendous readership. What engineer cannot read about how you have 3 wires and make 5 mistakes? And yet, I clearly said, you wouldn't believe it, but this is what happened. So the headline, trite as it sounds, is very, very important. Sometimes there's a subhead, and that's important, but if you don't get past the headline, the subhead is only an amplification of the headline. And a good writing, the headline is an important part of the story because it guides the audience, it guides the author. The headline forces the author to stick to a certain storyline and not go wandering off into little ravines and eddies and so on. So those are one of the things I've learned over the years in writing.
That,
You know, I
that
think,
last, go
I'm
ahead.
sorry?
No,
You
go
think
ahead.
what? I think, you know, the other thing I get asked is by people, what is the most difficult part of engineering? And my answer is fairly easy. I think debugging is the most difficult part of engineering. The reason is it can only be learned. It's very hard to teach, and you have to learn it through the school of hard knocks and experience. There are so many ways to, you know, debug and make incorrect assumptions or assume correlations and causalities where there aren't anything. When you have two faults in a circuit, you might assume one's connected to the other. They might be totally unrelated, or one is causing the other. It may not be the case. Debugging is a skill, it's an art, it's a combination of experience and hunches. I have never seen a good article about debugging other than some, you know, high level thing. There is, however, and this is a sign, there is a book about debugging, which I happen to have a copy of right here. Thank you. I don't know if you can see, it's called
Yes.
Debugging, the 9 indispensable rules for finding even the most elusive software and hardware problems. So the headline is debugging. That's a great headline. And it's by a fellow named David Agans, A-G-A-N-S. I talked to David Agans and I said, why is your excellent book, which is a hands-on engineering book about debugging, published by the American Management Association? I assumed to be some high-level, you know, how to manage debugging. He said, they were the only ones who accepted it and published it. Very simple. But I'll be honest, every time I look about a story about debugging, it's usually about a specific case. Here was a problem I ran into, and here's how I debugged it. We ran into a lot of, you know, dead ends and bad alleys and so on. And all those stories are true and interesting, and they get a lot of attention. Engineers love to read about other engineers' problems and how they solve them, whether it's a design problem or a debug problem. Always a good story. However, I've never seen, except for this book, a general treatise on how do you go about debugging in a logical, coherent, and technical manner. So I would recommend this book, which is modestly priced, I assume, to anyone. But at the same time, if you want a good story to attract people's attention, talking about a problem you had and how you debugged it and where you went wrong, engineers love to read where other engineers went wrong and how they got on the correct path eventually. And every engineer has stories about that. There are very few cases where I had a problem and, you know, it was easy. It could be this thing was malfunctioning, I took it apart, blah, 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 and, you know, it was acting flaky, and lo and behold, the battery was on the edge. It was just on the edge of the right voltage so the thing would work and not work. When I put it in a brand new battery, it worked great. So I wasted all this time trying to debug the circuit and look for problems when it was just the battery was right on the hairy edge of being good enough.
Wow.
I myself have done this. And
Oh,
every engineer
wow.
will go, oh, yes. So I assumed that the thing was working sort of, therefore it wasn't the battery, therefore it was a, you know, intermittent connection or who knows what, or a thermal problem, when it was an obvious problem. The battery was right on the edge of where it should have been. So debug stories do well as long as you cast them with a little bit of a, you know, broader lesson if you can. And every engineer has a debug story or two. And that applies to mechanical engineers, electrical engineers, probably to software engineers, but I think their debugging approach is very different because for software, it's very easy to do and undo your stages. You can, you know, take out a line of code, put it back in. There it's really a matter of just keeping track of what you're doing. We're very electrical and mechanical engineering, particularly mechanical, debugging is tough. Once you drill a hole, it's hard to undrill that hole.
Yes.
You know, someone described to me the difference between electrical engineering and mechanical is in electrical engineering, it's hard to find the problem, but easy to fix it. In mechanical engineering, it's easy to see the problem, but hard to fix it. And there's some truth to that. In software engineering, I don't know. I'm not close enough to debugging that. But I think those are stories that work well, debugging type stories.
Okay.
And again, every engineer's got one to tell or more.
Indeed. Indeed. You could probably fill volumes.
Exactly. And a good debugging story will get interest.
This is, well, what happens when you have to communicate with people who aren't engineers? How do you handle those cases?
It's very difficult because you have to simplify it and you're not being misleading. And it's tough. The first thing is try to find out what level of scientific background they have, if any. Then you resort to analogies, and analogies are tricky. They can be useful, but very misleading, or they can be useful and reasonably good. An analogy I often use when talking to non-users about basic of voltage and current is water. It is a legitimate analogy to use water pressure as an analogy for voltage, water flow, amount of water flow for current. And then thickness of the pipe can be resistance, an opening of diameter of the pipe. These are all legitimate analogies. In fact, the equations used for water flow and the ones for electrical flow are very similar. A capacitor is a tank of water. A resistor is a curly pipe of water. And if you say to the person, we're talking about voltage, which is the pressure of the water, or the pressure of electricity, versus the current, which is the amount of water flow or the amount of electric flow, the volume, they sort of get that. Beyond that, it's tough. I wanted to describe to someone the difference between ultrasound for test and measurement and X-rays and MRI. Ultrasound, they sort of get, it's an echo. And they know what an echo is. Okay, it's an echo, it's too high to hear, but they get the idea. The time of echo gives you some information. X-ray, they can sort of understand. It's a picture, but instead of light, you're using waves that are beyond what you can see, and they go through stuff. Try to describe an MRI to a non-technical person is almost impossible, because it begins with the magnetic moment of atoms and how it gets twisted by magnetic fields and goes back. They have no idea what you're talking about. And in fact, there's no analogy, no way to describe an MRI, in my opinion, to a non-technical person without totally glossing over how it works. So there are cases where you can convey the information to a non-tech person, and there are cases you can't. Laser stuff, it depends. I mean, they understand laser, highly focused, powerful beam of light. But the fact that it's coherent, that's a tough message to get across. You do what you can. But it is tough. Talking to the non-technical person is a real challenge, and I generally avoid doing it if I can, unless you're having face-to-face contact. Then you can see if they're getting the story or not. If you're doing it online through a printed, so to speak, story, it's very hard to understand if it's working or not.
Right.
We as engineers bring so many assumptions to the story of what is understood and what is understood, that it's a real challenge to understand. Does this person not understand at all what I'm talking about? A problem. But sometimes it works.
So when people meet you at, say, a dinner party or something, and they ask what you do, how do you explain that?
I tell them I am a former hands-on engineer who writes technical articles for engineering companies or engineering outlets for an engineering audience. And I say, sometimes I try to simplify it, sometimes it's not possible. But the audience is not necessarily looking for simplification as much as understanding. And they usually walk away at that point. Because frankly, it's tough. It's tough. Again, you try to use analogies. You try to talk about exciting developments, if there are some that are available. That does happen at times. If you can, there may be something they can grasp, and they say, "Oh yeah, I understand that. I've seen that."
Yeah.
You do what you can.
Yeah, absolutely. How do you handle situations? You talked about the written word, so you're very good at that. What tips can you offer for presentations?
It'd be the classic tips. If you're doing a PowerPoint presentation, nothing is PowerPoint. Keep the slides short. Don't read the slides to your audience. Your audience knows how to read, I would hope.
Yes.
Use a few, less is more, a few visuals or graphs, even occasionally throw in a humorous visual, even if it's relevant or not, to break up the flow. Otherwise, you end up just talking and droning on and on, to some extent like I'm doing. But, there are some humorous cartoons. Pull in a Dilbert. There's always something you can find in Dilbert that's relevant. There's a painting by the surrealistic painter Max Ernst, E-R-N-S-T, called, it has different translations, but it's called Man's Head Puzzled by the Flight of a Non-Euclidean Fly. The audience doesn't know what that means, but it's a wonderful painting. You Google Ernst non-Euclidean fly, you'll see this painting. Some guy with weird stuff going on in his head, totally confused. It's some surrealistic picture of some guy's head. And he say, "Are you feeling like this now?" You put that in the PowerPoint, and that gives them a chance to breathe. So every 10 slides or so, a little comic relief is good. Nothing controversial. Just are you confused here, or a Dilbert, or something like that is always good. Never hurts. But keep the slides simple, and don't read them to the audience. I have seen PowerPoints that were dreadful with the presenters reading data, table of pairs. My feeling is, if you can summarize what you're trying to say crisply, then you need to go back and work on it some more. You're not giving an academic paper. You're giving a summary to an audience at varying levels, and it depends who the audience is. And I found engineers are actually pretty good at that if they work at it, but they've somehow been told, oh, engineers can't write, engineers can't do this. No, it's just a matter they need guidance. It's, you're off track here, get back on track, or could you simplify that a little? And they're good at that if they have a coach. You might say it's like a producer. It's like when you see a person on TV, you go, oh, they're a brilliant actor. No, somebody wrote the script, somebody directed them. They may be a good actor, but that's only 1/3 of the job. They need a producer, a script writer, a director. I think engineers can write and can do verbal explanations with a little guidance. And I think it's probably one of the best things to do is, it sounds trivial, rehearse it in front of an audience that will be genuinely critical in a positive sense. And that audience has to take off its engineering hat, if it is an engineer, and put themselves in the position of an average person on the street, if that's the audience. Obviously, if you're pitching to venture capitalists, hopefully they got some smart guys. You don't have to simplify it. And the other thing is to avoid words that make the audience doze off, like revolutionary. Very few things are revolutionary. Important step forward, dramatic improvement, all good, but don't say revolutionary. That's a cliche. And as the George Orwell essay will say, cliches are the death of clear presentation. Because they're lazy, it's essentially they're dishonest. We don't have revolutionary developments till we have hindsight. So how can you say in advance it's revolutionary, When the laser was first demonstrated in 1960, I believe, the visible laser, not the microwave laser, many of the reporters at this big Bell Labs or whatever press conference said, this is nice, this is a solution looking for problems. We have no idea what it's going to be used for. It's a joke. Well, we know the story of how the laser became. No one at the time said it's revolutionary because nobody knew what to do with it other than, hey, this is amazing, a coherent light source. And it was red, so it was visible. So, avoid those common traps is what I would say. Traps are easy to fall into and hard to dig your way out of. So I'll give you another analogy situation. I was asked by someone once, why does a rocket have to reach a certain velocity to escape the Earth's orbit? Which is a very reasonable question. It's about 17,000 miles an hour. And, can't you just go slower and slower, start at a mile per hour, build up your speed a little bit, eventually get there out of orbit? Why do you have to go so fast? And I used an analogy, which I got from, I think, a NASA booklet of, suppose you're in a hole in the ground, you're, dug a big hole, you're in it. You can climb out of that hole, your fingers and your feet, by grabbing onto the sides of the hole and climbing out, hopefully. Slowly, but you'll get out. Now imagine that hole is made of sheer ice. You'll never climb out unless you can get a fast running start and leap out of it. When you're trying to escape the Earth's orbit, you're in a hole with sheer ice. There's nothing to grab onto. You have to get that running start and get out.
Okay.
And that brought it clear to people. I've used that with people. Oh yeah, now I understand that you can't just incrementally, a few miles an hour and a little distance at a time work your way out of orbit. No, you have to reach that fast run to jump out of the hole. And that hole is called Earth's gravity. So
wow,
I think analogies like that can make things clear because everybody can understand I can climb out of a hole that's got dirt sides, but I can't climb out of a hole that's got sheer icy sides. So
wow.
And I think understanding what analogies work for your audience without being misleading is tough, but can be done. When you get into things about physics and device physics, it gets very tough, frankly. So I tend to not try to talk about solid state physics to a non-technical audience. It's very tough.
Yeah. They probably wouldn't care much either.
Yeah. And the average non-tech audience is confused about words like energy and power because they're used interchangeably by the broader community. From an engineer saying power and energy are quite different, engineers themselves are the worst enemies. They often use the terms interchangeably because the audience they're talking to knows the difference. They'll talk about, I don't have enough power to run this. You really may mean I don't have enough energy to run this for a certain amount of time. Energy is the accumulated power, and power is how fast you use the energy. But you got to be careful is what it means, because if you get sloppy in your terminology, it leads to sloppy thinking and sloppy presentation. So you don't have to be precise, but be careful, at least is what I say. I'm always very careful when I write to distinguish between energy and power, even to the engineering audience, because in energy harvesting, which is a hot topic, you collect little dribs and drabs of energy. You harvest them and you collect them in a capacitor or whatnot, and then you spend it as power at a certain rate. So it's like saving your pennies. When you have enough pennies, you say, now I got $1, I can buy a candy bar. So you're collecting it slowly as pennies, that's energy, and then you spend it, that's power at a certain rate. Again, a valid, legitimate analogy that the audience can relate to. But engineers have to be careful with the terminology. Sloppiness can be infectious. in a bad way.
I like that.
So,
Sloppiness can be infectious.
yes. I should have warned you. I don't like to talk to people, but I can talk a lot when I get going.
That's all right. That's all right. I prefer you do the talking.
Okay.
Uh, Earlier, you said that engineers can be good writers if they just have the proper guidance.
Yes.
Did you have any guidance when you were going through that phase?
Yes, I did. I had a mentor, Dan Scheingold at Analog Devices. I worked directly as his assistant. He was the third employee of Analog Devices. And
Wow.
his job when hired on was to create collateral, data sheets and application notes and so on. He was a very careful writer and very careful in his choice of words. And subsequently, he became the editor of the in-house publication Analog Dialogue, which went out to thousands of people, millions of people, I don't know, lots. And I became his associate editor. And under his tutelage, I learned how to write carefully, to understand the audience's needs, to be careful with phrasing, to be careful and read it back and say, is that statement ambiguous? And a lot of times I'll read something and someone writes, say, did the second half of that sentence refer to the first half or to something else? See, it's very important sometimes to put aside what you wrote and then read it later. Or, and I know this sounds stupid, read it out loud. Because a lot of phrases that are awkward only become awkward when you read them out loud. Mm-hmm. I know it's a pain, reading a whole book out loud in front of a book is painful if I've done it. But, a 1,000 or 2,000 word article, you can read that out loud in 20 minutes. Read it out loud and say, that sentence have flow, is that sentence awkward? What does the sentence refer to exactly? Another thing I find in engineering writing, which reading out loud happens, is too many pronouns get involved. After a while, you're unclear. It's what does that pronoun refer to? It, they, it gets like spaghetti. Is that they refer to this component? Does it refer to the noise? So you have to be careful. And, use of the pronouns is okay, but overuse of pronouns can be very tricky. So you've got to watch out when you're getting into this pronoun swamp. I have a friend who shall remain nameless when they talk. He said this to her, and then she said, and after I say, who's talking to whom here and saying what? And you have to be careful when you write because you are so close to your subject, you know it so well, you don't realize the pronoun mess you can get into. So that's one of the things Dan taught me was to read it back the next day if you have time, hopefully, and say, is this sentence clear to someone who's never heard it before?
Okay.
That's what you try to do. So I cannot pay enough tribute to what Dan Scheingold, now retired, taught me as he was editor of Analog Dialogue, and dealing with an engineering community as they were the authors, or we would write their stuff for them after we talked to them, and then the audience and understanding what the audience's expectations were. Clarity and precision without sounding petty is always a challenge. It's tricky to be precise without sounding like you're nitpicking. It can be done. Again, differentiating between energy and power is a simple way to be precise without being nitpicking. So
that's good. I like that. Do you think that? So I'm assuming when you were in university, they didn't teach all of this.
Not at all. Didn't teach anything. Getting out of school and getting that first real job was the best thing that ever happened because I learned, learn how to write reports for the boss, design reviews, and get it organized and explain the issues, the problems, the trade-offs clearly, why you made certain decisions, and maybe explain I made this decision because of this, but if you're willing to spend 10 more cents, we can do that. So, you learn about the engineering process of explaining what you've done. And, engineers don't like design reviews, but actually they're very good for focusing what you've done to a technical audience who's somewhat familiar with what you're doing, fellow engineers, as well as, the boss. There is a book, which the name I forget about, one of the Mars rovers that landed, and he talks in depth, I can get the name later. I keep a list of engineering books, but he talks in depth about the NASA's engineering reviews, the JPL's engineering reviews for the design early on, and all the questions that were raised. And boy, that's brutal. I mean, that's, they have to ask them everything. Thankfully, my design reviews were never that tough, but it makes you think about the kinds of questions that are legitimately asked at a design review and how you anticipate them. What if questions, and why did you do that? And have you considered this? So I'm just saying, those are good things. The worst thing in a design review is the guy who comes unprepared and starts asking stupid questions. You kind of have to learn to ignore that. You do like the one who has read the material and asked good questions. When I was at Analog Devices, there was one senior fellow who was a genius on some days and out in space on other days. If you had him at a meeting on the day he was out in space, you never knew what you were getting. if you had him at a meeting on the day he was being brilliant, he would ask insightful questions and pose good points and say, gee, I wish I thought of that, or yeah, we did think of that, here's what we did, and he would say, good thinking. That was very valuable. So, learning from fellow smart people always helps, because you have to make a case to them. And these people are not fooled.
That's a good point. Yeah, it's hard to fool engineers.
Yes, they know when you're blowing smoke at them. Believe me, they really do.
How do you know when an email will suffice versus writing a full-on document?
I generally find emails to be only good for short explanations, because you don't have any feedback from the audience as to whether they're getting what you're talking about or not. If someone asks a direct question, did you make a mistake here? I don't understand this. You can answer it, of course. Broader things are very tough to explain in an email. I'd rather say, let me start at the beginning and explain what I've done here. Let me set the context so we have a common framework of understanding. I think that's very important, because you can easily have a situation where, in engineering especially, there are many words that have the same word has very different meanings. I use buffer as an example. The word buffer is like, six blind man and the elephant. To an engineer, to a hardware guy, a buffer could be, hardware piece in an IC. It could mean who knows what. To a software guy, it's a chunk of software.
Yeah.
You have to make sure everyone's got the same context for the words. So the same word has very different meanings, and then the flip is true. Different words have the same meaning. So an engineer I'll talk to an engineer, he'll use three different words for the same thing, and I'll know what he's talking about. But an engineer, or it's not as tuned into the subject, will not know. Why do you use three words? Are those three different things? So common words that cause problems are buffer, driver, a great word. There are software drivers or hardware drivers. There are drivers that drive MOSFETs. There are drivers that drive communications lines. There are drivers that are really interposed between a signal and an A to D converter.
Yeah.
It's really a buffer, but it's also a driver. So, those words, there are certain words you got to be very careful that the audience, even if technical, understands where you're coming from when you use that word. Several times in the past, I was almost roped into working on a technical taxonomy, where non-tech people would like to have a family tree of all technical stuff. I would run real quick from that, because it's an unsolvable problem. Because anytime you define components and their functions and whatever, you run into this problem. The same word has different meanings, different words have the same meaning, depending on the audience, depending on the project. And you'd run into this with buffers and drivers especially, and it was a hope, because one man's input is another man's output, frankly. Depends on your perspective.
Yeah.
So that's why when you talk, you have to be clear. When I'm talking input, it's his output. Another thing on data sheets that always came, I did have an email, I remember many years ago, as an applications guy from an engineer saying, you say this op amp can drive 1,000 picofarads minimum. Does that mean I have to put 1,000 picofarads on it? And it turns out in datasheet talk, when you say minimum, you mean it is functional with up to at least 1,000 picofarads.
Yeah.
So that minimum is really the maximum. Whoa, you're saying minimum is really maximum? How can that be? Once you explain it, oh yeah, now I understand. But just reading on the datasheet, this op amp will drive up to 1,000 puffs minimum. They go, well, that means I have to hang 1,000 puffs on it. I don't want to do that. So again, as an engineer, where you stand on the matter depends on where you sit, is a way to look at it. So that's the advice. Think about the audience's perspective and context, what they know and what their frame of reference is when you do this.
You just use the term puffs for picofarads.
Yes, exactly. Exactly, because everyone I talk to knows what that is, or what a farad is. But I'm just saying, you do have to, understand. That's why it's very tough to do in writing unless you really know who the audience will be. If you're writing for an engineering publication, a site, you understand. In more general, it's very tough to do it in writing. Sometimes sidebars when you're writing are very useful. A sidebar is a box off to the side, out of the mainstream, and you either use it to define key terms, or have a little mini tutorial, or to talk about what all the acronyms are, summarize all the acronyms. Very helpful. When I watch British mystery shows on TV, one of the things I found I had to do was write down the names of the characters and who they are. Because after about the first hour, you forget, who's that? Is he so-and-so's cousin? Is he so-and-so's nephew? You get confused because it's a multi-part show, but you forget. So in effect, that's a sidebar I create with the name of the character and what's their relationship and how they play in the story. A cast of characters type thing. Well, it doesn't hurt in an article to have a sidebar defining acronyms if you have more than a few. It doesn't hurt to have a quick tutorial if you think the audience may not understand it, or maybe a quick context setting. The reason we undertook this project was XYZ, to solve a problem. I've done stories, for example, on the history of air conditioning. And a good sidebar in that was, how did it come about? Well, it turns out the fellow who developed air conditioning, we know it, was commissioned by a printing plant that was having problem doing printing and color printing because the registration would vary with the humidity of the plant. And his task was to come out with a way to control the temperature and the humidity. And he figured out air conditioning as we know it.
Wow.
That's a great little sidebar, but it also says,
Yeah,
how did
yeah.
this come about? Now, you wouldn't want to put that in something in the main line of the story. It could be distracting. It's a great sidebar. Sidebars allow you to present information without distracting the reader from the main theme of the story.
Oh my God. I'd like to read that article too when you get to.
Okay. If I can find the link, I'll send it to you. But
Okay.
you know, those things are good sidebars. Historical context or a little tutorial inside, and that way the reader doesn't feel imposed upon, and they can look at it without losing their train of thought. The other thing is acronyms. Some publications, like every acronym, do not defined up front in the text. Others are flexible. If you're talking to an engineering audience, you don't have to define that the acronym MW means milliwatts.
Right.
To a non-engineering, maybe. Defining acronyms in line can be very upsetting to the reader's flow of reading the visual material, frankly. Only do it when it's necessary or called for, is my opinion.
Okay.
Yes, you have to do it if you've got these military acronyms that are gobbledygook, sure. But be careful. KWs, kilowatts, you don't need to define it for the engineers. Or be very careful about how many is designed. It's like being in a boat that's in choppy waves. If you're defining every acronym as you go along, it can be really unsettling to the visual flow of the story. So
I guess that's why so many books have those. They haven't defined at the beginning.
Exactly. And in an article, you don't have that luxury of defining it in the beginning, but a sidebar is a good thing to do. So, you know, those are many of the tips I've learned, you know, been taught or learned over the years. The other thing is on the web, when you had a printed publication like a magazine, format was very important. Every article had to have the same look and feel because the person would thumb through it. And these magazines have style guides and whatnot, you know, how to do it, certain formatting, certain typography, certain things. On the web, every article by and large stands by itself. So format is not as critical, believe it or not. And it's been in some ways liberating. You don't have to worry that, you know, the look and feel, unless whoever you're doing it for insists, the look and feel does not have to match the previous one. Graphics and printed publications all have to have the same look and feel. Schematics were constantly being redrawn by the publications to have the same look across all articles. Necessary, because as a person thumbed through a magazine, they would want to see the same look and feel of schematics.
Sure.
However, on the web, articles are standalone. You're not thumbing through them. So you don't have to worry about it. If the schematic is clear to the intended user, let it go. And there are companies from whom I use their schematics as is because they're beautiful. They're drawn by a human being. And that's the other thing. A lot of articles, technologies come with CAD drawn schematics. To be honest, they're only legible to the guy who did it. To other people, they're like hieroglyphics. So you may have to redraw it to be more legible and have more of a flow of visual appeal. I did a blog once about a wonderful product that had an absolutely incoherent schematic. And I got a lot of reader response saying, it wasn't a complicated schematic, but I couldn't figure out where the signals went in, where they went out, what the flow was, because the schematic was drawn by a computer-aided program, and the engine who did it knew what he was doing, so it didn't matter. Nobody outside of this person could follow the schematic. You needed like a Rosetta Stone.
It's
so I would
sad
say,
when you.
Yeah.
Oh, sorry. I was going to say it's sad when you can confuse a fellow engineer.
Exactly.
You know?
So, you know, think about, you know, I'm so close to this product. I know what the inputs and the outputs and then whatever's are. Will the audience understand it? And the answer is probably not if it's a CAD-based schematic, unless you're careful. So a hand-drawn schematic or one that's done with an eye towards visibility and legibility is always preferred. Same thing for mechanical drawings. I mean, a good CAD mechanical drawing is very useful. It's all the information you need. It may not have the key points highlighted. It may have too much information, or it may not have the important information brought up to the front or highlighted. So you want to do that. You know, what's important? The outer dimensions, the hole size. It depends, of course. But on a CAD one, everything has the same level of importance, which is not the case when you're trying to talk to an audience.
Sure.
So,
what would you say, having made that transition from just engineering to engineering and writing, what's the biggest benefit that you've seen?
For me personally, it's that I don't have to hunch over a circuit board looking for picosecond glitches. Believe me, it was frustrating. You know, you have that moment of personal revelation when you hunched over the board with a scope in a dark room looking for that elusive intermittent glitch. But it also means that I get, in effect, the opportunity to keep up with technology and technical developments. You know, obviously, technology always moves forward, and I get to read about it and talk to the people who are doing it and ask them questions. And one of the questions I always ask is, one of the many questions is, what, not only what drove you to do this, what enabled you to do this at this time that wasn't available a year or two ago? And they may say a new tool, a new material, a new understanding of this or that, but you know, they're usually pretty good about answering it. I have found engineers, despite the reputation of being you know, not articulate, that's not true. They're very articulate when they're talking about something they know about to someone who understands what they're talking about. So I'll ask them, what development allowed you to do this at this time? I'll also ask them, what were the biggest impediments you come across while doing this project? Where did you come to a junction where you had to decide to go this way or that way? Or where did you go in a certain path and say, this is not working, I have to go back and start again at a junction point. I thought this was going to work. We pursued that path. It dead ended for various reasons. What were the reasons? We went back and revisited our initial decision. Engineers love to talk about that. The problem with many articles is they talk about design as a linear process. We had a problem, we decided to do this, we did this, we succeeded, we're done. That is not engineering development. Engineering is, we had a problem, we looked at the options, we weighed the trade-offs, we pursued some of them. It didn't always work, we had to go back and start again or revisit the trade-offs. And understanding where that happened is of great interest to most audiences. And most designers will talk about that if you ask them politely and nicely. Because in the end, they're proud of what they did. And it's no shame to say we didn't figure out all the time. Engineering is not a linear deterministic process. And if you talk about it as having not so much a random walk, but unknowns, difficult problems with difficult trade-offs, that makes a good story. I also ask people, you know, what made you do this besides, you know, management said, I mean, what made you think this was a viable thing to start working on? What did you hope to solve for your customer? What problem? You know, you didn't just do this to amuse yourself.
Right.
What's the customer's problem that you're trying to help them with here? And how did they solve this problem in the past? That's another great question I ask. Up till now, when you release this great product, how did they solve this problem? And often, well, they had to cobble something together, or they solved it, but the trade-offs were unpleasant. And our new product makes the trade-offs far less unpleasant. Good answer. So those are questions I ask people. And engineers generally like to talk about that. They're proud of their work, and rightfully so.
That's good insight. One final thing, I know we're coming up on time here.
Like I said, I warn you, I don't like chit-chatting, but I like to monologue.
What would you say to, because a lot of engineers, kind of like what you talked about earlier, they assume that they don't need to be good communicators. You know, I'm a good engineer and that's good enough. What do you say to an engineer who says, oh, you know, communicating, that's for the sales guys, that's for marketers?
I would say the best technical marketers are former engineers or previous, where I worked at Analog Devices, almost all the marketing guys were hands-on designers at one point in life, because the audience that they were trying to sell to were engineers, number one. Number two, you know, and if you leave your product explanation in the hands of non-technical marketers or salespeople, there are going to be a lot of mistakes made. They're going to make promises that are not true, make claims that are quite true. Whereas as an engineer, you can say, yeah, that's true, but, or only under this circumstance. So it's in your best interest to represent your product and your developments, both your interests professionally, personally, technically, and so on. It's good, and you can be honest. You know, I come from a world, in the analog world especially, unlike the software world, the data sheet is the where you open the kimono. I've written a zillion press releases, and a press release is brief, and you have to gloss over a lot of issues by definition. You can't discuss every nuance. But a data sheet, which is where you talk all about the product's realities, and you talk not only about typical characteristics, but minimum and maximum characteristics. So a data sheet is where you really reveal the product to the intended audience. And a good data sheet is worth a fortune. And you know, we basically say to the customer, we will deliver a product that meets this data sheet at this price. And if you have a good data sheet, then you can start telling stories about the product. How did you achieve such low temperature coefficient of temperature performance? How did you achieve, low drift or whatever it is, low input bias current? So the data sheet talks about the virtues of the product as well as its actual performance. And the front page of the data sheet is always revealing because that's where you highlight the best parts, features of the product. And now you have to ask people, I'm looking at your data sheet. How'd you do that? How did you get 10 picoamp bias current? Who wants that anyway?
Mhm.
Right there. And they love
Yeah.
to talk about it. And also I said, in order to achieve that 10 picoamp bias current, what did you have to give up in the design? And they might say, well, the cost was more power dissipation, but the audience is willing to accept doubling power dissipation in order to get 10 times better bias current performance. So looking at the data sheet is always good, particularly if it has min and max specs. Typical specs are just sort of like a foggy, but a good data sheet has min and max, and there's a lot of, I've always told people, you can have a basic op amp, which is the simplest analog building block.
Mhm.
You can have a 50-page data sheet with graphs left and right about performance under every circumstance possible, and that's good stuff. Now, writing that data sheet's painful, speaking from experience, but the audience loves it, but it also gives you something to talk about and ask about. So
That's
beyond
good.
the press release is a good overview, but by nature, it has to gloss over things. That's just the way it is.
Okay. One final question.
Sure.
You were fortunate enough to have a mentor, to have
Yes.
someone who took you under his wing.
Yes.
For engineers who don't have someone like that, what can they do?
It's very tough. I think find someone who's a good writer and ask them how they got into it. Ask them the questions you're asking me. I should also mention I had another mentor, Al Hahn at Analog Devices, and he taught me how to write good press releases, how to market outward to the more general media audience, which consisted of both technical and semi-technical people. So I want to give him credit too. And he was my boss for some years. But there were two audiences we in effect dealt with. One was the engineering only audience who read the analog dialogue publication. One was the general media audience who would read press releases, and that would vary from non-techies to techies. And how to appeal to all of those in a given document is always a challenge. And Al taught me how to do that in a few words. Back to your question, get a mentor, get someone who knows how to write. There are people out there, and look in publications or websites and find people whose names show up repeatedly, and say, how did you learn to write? And make sure it's someone who has a qualified technical background. Nothing personal, I find journalists are the worst because I met with a lot of journalists, and not to slander them, they're semi-lazy. But the danger with journalists is I think they can in 10 minutes get smart enough to do a good job. Can download an article on Wikipedia. What happens is they end up knowing the words, but not the story behind the words. That's very dangerous. They can tell you, oh, I know, such and such as I know the definition of. Well, knowing the facts and knowing the story are two different things. So a journalist, by and large, think they can in 10 minutes get up to speed. So you want someone who's got a sufficient technical background, whether they're a qualified science writer or an engineer. I read a publication called Photonics or Optical Spectrum, two publications. And there's one name, Jeff Hecht, for example, shows up repeatedly. He writes wonderfully, and he has a technical background. I don't know if he practices as an engineer, but he has a very technical background. He writes great stories about what's going on in optical engineering and the developments and how they play. So if you don't know someone, contact, reach out if you can. Now, like I said, journalists are generally not a good source, in my opinion. They think quite a bit of themselves. I once went to visit an engineer, a physicist at Bell Beranek and Newman. They were doing some kind of laser stuff, and he started talking about the physics. And I answered him his questions with his answer with follow-up questions. He said, "Oh, you really understand what I'm talking about?" I said, "I think so." He said, "Well, I had a reporter in here from a local paper, and they knew every word I said, and they didn't get it all I was talking about." I said, "I'm so relieved to talk to you." And that just reinforced my low opinion of most journalists who pretend to be technical, as opposed to science writers or engineers who are writing. So, rule one is know what you talk about, know what you're talking about. And rule two is don't try to look smarter than you are. If you don't know what it is, ask. I mean, I've talked to smart people and I said, back up a minute, I'm not familiar with XYZ. Usually having to do with solid state physics, deep diving into that. And, they'll explain it. And they say, well, I got this energy well, blah, 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 fine, good. So if they think you're asking an honest question and you have sufficient background to understand the answer, you're okay. Don't pretend you understand what they're talking about when you don't, because you'll probably miswrite what you heard. And that's embarrassing. Sometimes when I write, I'll say, I didn't understand you here. Could you clarify this point? And that's good. That's good. And when I send it back for review to the whoever I'm writing for, said this point wasn't clear. Were you referring to X or Y at this point? Okay.
Good point. All right. Well, I'm going to stop it there because I know I've got like 3 pages of notes.
I'm sorry.
This is good.
I warned you.
No. Don't apologize. Here is the tricky part here is trying to condense it now.
Yes.
To go back and write.
That's another thing. I hate to record conversations and try to transcribe them later. It's time consuming. It's difficult. There are automatic transcription services. They don't work very well. I find it's best to try to take notes as you go.
Yeah.
And if it's a discussion, I'll flag what time the discussion it had. I often have a stopwatch going. And I'll say, he made a good point at 15:32. So I can go back and look at what he said. But take notes on the fly. Trying to transcribe it is painful and error prone and just a waste of time. Take notes as you go and mark what's important. Circle the important phrases, go back and check what the person said there if you're not clear about it. Learn to take good notes. It sounds in this day and age like a stupid thing to say, but it's actually a very good skill.
Good to know. Don't be surprised if I email you after this and ask you to clarify some of this stuff.
Many years ago, I worked at a summer job at a company that made photo cells of some sort, and the owner was a real old guy, and he had a electric typewriter, IBM, we're talking that old, and he said the best skill, this is before computers, he said the best skill you can learn is learn to type. I laughed at him. It turned out he was right for the wrong reason. He was right. Learning to type was great, but not on a typewriter, on a keyboard of a computer. But I'm saying, skills like taking notes are very important. And if you're not good at it, figure out how to get good at it. Because if you're talking to someone, you can't stop and type. You can't transcribe later.
Yeah.
Learn to take notes. It's okay to say this one. Hold on a second. I have to write that down. People don't mind. They know that. I also tell people when I talk to them, I'm recording you. I'm not recording you. The answer is I'm not recording you. That takes the fear factor out. Many people do not like to be recorded because they're afraid they'll say something wrong. So the first thing I say, I'm not recording this conversation. I'm taking notes. If you don't mind if I have to say, please wait a minute. They say, oh, that's great. So,
okay. Well, fortunately, I'm recording this.
I know, and I don't mind. Please don't repeat what I said about journalists.
I'll leave that part out.
Okay.
Of course, if they watch the video, but
that's okay. Well. I have evidence to back up my contention. Believe me, I can name names.
It's when you talked about taking notes, do you actually take shorthand, or do you just
just
write down
write keywords, key phrases, and that reminds me, what to follow up. And it's funny when you talk to someone, certain phrases will stand out, certain points they make will stand out. Particularly if you're asking good questions. What stopped you from doing this previously? What allowed you to do this now? What problem are you trying to solve? They'll answer the question. So if you have good questions, don't let them ramble on. Because, if they ramble on, you're just going to have a lot of rambling, like I was doing for the first half hour. But if you ask questions, they'll have answers. And you write down the answer, and then you can backfill later. But, that's why good questions lead to crisp answers in most cases. So.
Okay. All right. Well, I will let that be the last question then. Thank you very much, Bill. I do appreciate it.
Thank you very much for putting up with the confusion.
No.
And good luck with your project.
Thank you. All right. I'm going to stop recording now.